Hello Year 10, welcome to the next lesson on sequences. Today we're looking at finding the nth term rule of a linear sequence. What we've done so far is what the do now task is, which is applying the rule to make a sequence. So we'll do a bit more practice of that, and then we'll look at how we find the nth term rule when given the sequence. So if you could please just write the date and the title, pause the video and have a go at this do now task, that'd be brilliant, thank you. Okay, lovely. So this is just exactly what we did last lesson. You might remember that we used the tables. Some of you might have chosen not to use the tables, doesn't matter. It's just a visual thing for the more visual learners to help them get their head around what we were doing. So for this first one here, remember, we're always assuming that n is 1, 2, 3, 4 and 5 and so on. So if we've done the first one correctly, we should have our sequences of 4, 6, 8, 10 and 12. Let's just check the first couple. So if n is 1, 2 times 1 is 2, plus 2 gets us 4. And then when n is 2, 2 times 2 is 4, plus 2 is 6. And we can see we've got that constant of adding 2 each time. And we did touch on the fact there is a link between the value with the n and your constant or your common difference, and that'll come into play today. So next one we've got 3n subtract 5, and that should be your sequence. Let's check the first one and the last one. So 3 lots of 1 is 3. 3 subtract 5 gets us negative 2. And then if n is 5, 3 times 5 is 15, subtract 5 is 10. And again, we've got our constant difference here of adding 3 each time. And we can see a link here with what's with our n. Next, we should have 8, 6, 4, 2 and 0. Start with 10 and take away 2 lots of n. So 2 lots of 1 is 2, 10 take away 2 is 8. 2 lots of 2 is 4, 10 take away 4 is 6. And you can see we're subtracting 2 each time. That's our term-to-term rule. Then we've got 4n plus 10, we should have 14, 18, 22, 26 and 30. And then negative 2n plus 6, we should have 4, 2, 0, negative 2 and negative 4. And we'll just check the last two. So negative 2 lots of 4, so negative 2 times positive 4 gets a negative answer of negative 8. And then we add 6 and we get negative 2. Negative 2 times 5 is negative 10, add 6 gets us negative 4. Perfect. Okay, so our success criteria today. So bronze is to recall how to apply the nth term rule to produce a sequence. We've just done that, so we can tick that off. Silver is to be able to find the nth term rule of a sequence and then to be able to analyse a sequence from its nth term. So can you find any term in a sequence when you know what the nth term is? And we'll look at that today. So first things first, we're going to look at how, when we're given a sequence, can we find out that nth term rule of a linear sequence? And if you look up here, that's the format that your sequence is always in. So our term, the number in our sequence, okay, is made up by something times n plus or subtract another given value. And they will always, whenever A is, A will always be the same case for any number in that sequence. And whenever B is, B will always be the same value for any term or any number in that sequence. But we'll look at how it works here. I don't want you to copy anything down at the moment, just watch for me. So the first thing we look for is our common difference, and that means what's happening to get from one term to the next. So what is the term to term rule? And we can see to get from 6 to 11 and 11 to 16 and 16 to 21 and so on, you are adding 5 each time. So the common difference is 5. That tells you what this A value is here. So the first part of your nth term rule is 5n because the common difference is 5. And well, we can now check if there's anything else come afterwards. So let's see. So we look at how the table has shifted. So we've got a string of numbers here, 1 to 17. Now, if we just had this as our nth term rule to produce this sequence, well, let's assume n is 1, 2, 3, 4 and 5 and so on. If n is 1, 5 lots of 1 is 5. If n is 2, 5 lots of 2 is 10. And if n is 3, 5 lots of 3 is 15 and so on. But that's actually not our sequence. 5, 10, 15 isn't the sequence. What we want is 6, 11, 16. So what do we have to do to the 5, the 10 and the 15 to get 6, 11 and 16? Well, we just have to add 1 on. So the second part of our nth term rule for that sequence is plus 1. So it's 5n plus 1. Let's check if it works. When n is 1, what's 5 times 1? Well, it's 5. Plus 1 gets us the 6 here. What about when n is 2? Well, 5 times 2 is 10, plus 1 is 11. And we can see that that always works because it's a linear sequence. You might want to pause the video and copy this down, which you're welcome to do now. If you don't want to, you can just move straight on with the next one. So another example, we've got a new sequence here. Now when you're trying to find the nth term of a linear sequence, where you've got a common difference like this, which is addition or subtraction of a value, you always do the same thing. So once you've got your head around this, it's dead straightforward. So first things first, we're trying to come up with the nth term rule that produced this sequence, 5, 8, 11, 14 and so on. So again, let's find the common difference first. And the common difference is 3. So the first part of our nth term rule is then 3n. So that common difference tells you what the value is with n all the time when you're working with a linear sequence, okay? But if we just applied 3n, if n was 1, 3 times 1 is 3. If n is 2, 3 times 2 is 6. If n is 3, 3 times 3 is 9, and then 12, and then 15. But that's not the sequence we've got here. We don't have 3, 6, 9, 12, 15. We have 5, 8, 11, 14, and so on. So we have to work out, well, how do we get from those numbers, when we've applied our 3n, to get to the numbers we want? Well, we just have to add 2. So the second part of our nth term rule for this sequence is plus 2. So 3n plus 2 is the nth term rule. Now getting a little bit more complicated here, in the sense it just looks like it is because it's negative numbers, but your process is the same. And we know that from last lesson you can have nth term rules with a negative n value. So let's find our common difference first. Now it's subtract 4. Now the common misconception is students will write plus 4 because you're ignoring the negative values. You say, well, 2 to 6 is add 4, 6 to 10 is add 4. But remember, when you're in negative and you're getting more negative, which we are, you're subtracting. So our common difference is subtract 4, which means that the first part of our nth term rule is negative 4n, okay? Well, if we apply that, and just be careful with this example, so when n is 1, negative 4 times 1 is negative 4, which is here. Negative 4 times 2 is negative 8. Negative 4 times 3 is negative 12. And negative 4 times 4 is negative 16. But we don't want negative 4, negative 8, negative 12, negative 16. We want these 4 numbers here. Well, how do we get there? So to get from negative 4 to negative 2, we're getting less negative, so we're adding on 2 each time. Please feel free to go back and look through these, pause the video where you want to, copy them down if you need to. Might be a good idea maybe to do this one and one of the addition ones with the positive integers just to refer back to. Okay, so we've looked at 3 different good examples there. If you could now pause the video, have a go at this task, and it says find the next 2 terms and the nth term. So it wants to know what is the rule in each linear sequence and use the process we've just used on the previous slides. Please pause the video as you do this. Right, good. I would expect us all to get the next 2 terms easily. So for A, you should have 13 and 15, and the nth term rule is 2n plus 1. For B, the next 2 terms are 25 and 29. You should have 4n plus 1. For C, you should have 33 and 38, and it's 5n plus 3. And I'm just going to fly through the nth term rules here because I'll assume that you found the common differences and you can work out the next 2 terms. So you should have 6n subtract 4, 3n plus 2, 7n subtract 5, 4n subtract 3, 4n subtract 1, 3n subtract 1, and then this one's a bit different, but we have used these before, we looked at it earlier, negative 10n plus 42, negative 4n plus 24, and negative 5n plus 29. Now I would expect everyone to be able to do A to F, or maybe even A to I without much hassle. If you've got those wrong, I want you to go back and look at the examples we did together and then have another go at them and make sure you can get to the right answer. Brilliant. Right, next stage, we're going to look at teacher example together. So again, this looks more complicated, similarly to how it did last lesson when we were trying to add terms to fractional sequences, but actually it's not. So the first thing we're going to do here is we're going to find the nth term rule. But there's 2. There's a rule for the numerator at the top, and there's a rule for the denominator at the bottom. So first things first, you could just completely ignore the denominators and look at the numerators. And we can see here, to get from 3 to 5 and 5 to 7 and 7 to 9, you add 2, so it's 2n, and then we don't want a 2 here because 2 times 1 is 2, we want a 3, so it's 2n plus 1, and then here we're adding 3 each time, so we get 3n, but if we've got n as 1 here, 3 times 1 is 3, we don't want 3, we want 4, so we add 1, okay? So it works the same way. So what I sometimes do is I cover up the denominator and treat the numerator like an individual sequence, work out the nth term rule, and then cover up the numerator and do the same for the denominator, and just make sure that I make it clearly as a fraction. Now, the next thing you can see here, it says change each fraction to a decimal. What happens to the decimal values? So you'll use your calculator for this, because we actually know a fraction is just a division. So you can write it as the fraction in your calculator. You might want to have a go now. So 3/4, press the SD button and you get to the decimal. If you don't have a scientific calculator, you can just do 3 divided by 4 and 5 divided by 7, and you get these numbers here. But that's not really, you want to know what the decimals are, but it says what happens to them. And actually what's happening is they're getting closer to a value of 2/3 or 0.6 recurring. Well, why is that important? Why should you know that? Well, if we were to cancel down our nth term rules, 1 divided by 1, a plus 1 and a plus 1, they cancel each other out, and n and an n cancel each other out, and you're left with just 2/3. Well, that's what we're getting closer to here. Okay, now this is quite challenging, but it's something lots of you are really capable of. What I would like you to do in a moment is pause the video and have a go at this one, and just repeat it. So find the nth term rule, remember for the numerator and the denominator, and make it into a fraction, nth term rule, and then turn each fraction to a decimal, see if you can work out what's happening and if that's somehow linked to your nth term rule. So please pause the video as you do this. Good, if you've got your nth term rule right, it should be this. So we can see here, to get from 3 to 7, 7 to 11, you're adding 4 each time, so it's 4n. 4 times 1 is 4, but we want 3. Oh, sorry, that should be subtract 1. Let's just check this one here. And then we've got 6 to 11, 11 to 16 is 5, so 5n. 5 times 1 is 5, plus 1 is 6, so we should actually have a subtract 1 there, so make sure bear that in mind. Don't worry, you're right, I'm wrong, so it has happened unbelievably. But again, if you write all of those fractions as decimals, you can see what's happening here is you're getting closer and closer to 0.75. Not 0.75, to 0.8, which is actually getting closer to 0.8 is equivalent to 4/5. Well, why is that important? The subtract 1 and the plus 1, the 1 and the 1, they cancel each other out. The two ends cancel each other out, which leaves you with 4/5, which is what we're getting closer to here. Okay, so really well done if you got that. If you're a bit unsure, don't worry. Sorry if I confused you by having a plus 1 there. So it's a subtract 1, but it still works the same way with cancelling them out, so that's not a problem. Right, next thing, finding a term using the nth term rule. So this is our gold criteria, so analysing a sequence. So the first thing we'll do is we'll find the nth term rule. That's what we'll do. So we're adding 2 each time, so we get 2n, really good at that. If n is 1, 2 times 1 is 2, but we want 3, so we add 1. And we know really that's what you're doing. You're multiplying your n value by 2 and adding 1, and you get your sequence. So 2 times 2 is 4, add 1 is 5. 2 times 3 is 6, add 1 is 7. Then it says, find the 12th term. Well, all that means is we're finding term number 12 in the sequence. So in this case, n is 12. So let's work that out. 2 times 12 is 24, plus 1 is 25. So your 12th term in the sequence would be 25. Well, what about the 50th term? And now with this first one, what you might think is, well, I'll just write the first 12 terms of the sequence out because it's plus 2, that's not hard. You're more than welcome to, that's not a problem. But when you're asked to find the 50th term or the 77th term, you don't be writing all those numbers out until you get to the 50th term or the 77th or the 100th, because it will take a while, we could make a mistake. So what we do is we substitute 50 in, because that's our n value, into our nth term rule. So you're doing 2 times 50, which is 100, plus 1, which is 101. Then we'll find the 22nd term. So this time n is 22. So we do 2 times 22 plus 1, which is 45. You might want to pause the video to copy this down. You're welcome to do that. If not, we'll move on to the next slide. So using this idea, where when you're trying to find a given term number, a term in the sequence, you just substitute that value in for n. So I would like you to use this nth term rule, 4n plus 7, to find the following terms for this sequence. Okay, so just remember, for this one, n would be 10. So you do 4 times 10 plus 7. This time n is 15. 4 times 15 plus 7. Okay, so we know what we need to do. Please pause the video and find those terms for that nth term rule and the sequence. Brilliant, good. So for the first one you should have 47 because 4 times 10 is 40 plus 7 is 47. Then you should have 67 because 4 times 15 is 60 plus 7, 67. Here you should have 407 because 4 times 100 is 400 plus 7, 407. so it's 4007. This time for E, n is 5, so 4 times 5 is 20, plus 7 is 27. For F, n is 23, 4 times 23 is 92, plus 7 is 99. Then we should have 127 and 107. Brilliant. If you've struggled with that, what it could be worth doing is you can make up your own nth term rule. You could do 2n plus 3 and then challenge yourself to find the 10th, the 50th, the 100th and see if you can do it. Right, for these ones, can you please find the nth term rule for each of them first, and then we need to do our gold level criteria. After you've done that, please use those nth term rules to find the 50th term in the sequence. What is the 50th term? What is it worth? Please don't write out 50 numbers until you get to the 50th term. Please use your rule. Please pause the video as you do this. Right, good. We should be able to find the nth term rules because we've done lots of practice. So the first one is 3n plus 1, 2n plus 5, 5n subtract 2, 4n subtract 3, 8n subtract 6, n plus 4. You might have put 1n, don't worry, but remember you don't need to put the 1 because n on its own tells us it's 1. 5n plus 1, 8n subtract 5 and 3n subtract 2. Now if you've not got these right, now might be a good time to go through and correct them because you'll have to then answer the next parts of the question again because you've probably not got those right either. So for all of these nth term rules, we want to find what would the 50th term be for all of these sequences if we were to write it. So all we're doing is we're substituting that 50 in for n. So 3 times 50 plus 1, 2 times 50 plus 5, 5 times 50 subtract 2. If you're now thinking, well now Miss has said that, I think I've not quite done it right, please pause the video and go and have another go at finding the 50th term. Pause the video once you do it, otherwise we're going to fly through the answers. So we should have 3 times 50 is 150 plus 1, 151. 2 times 50 is 100 plus 5, 105. 5 times 50 is 250, subtract 2, 248 and so on. And these are the 50th terms for each of those nth term rules. So if you were to write out the first 50 terms in each of those sequences, they are the 50th numbers, the 50th terms you would get. Okay? Right, again, gold criteria, so lots of that today. So just stay with me. So we're going to look at this sequence. And what the question is which term is the first to be greater than 50? Now again, you might choose to just keep writing these numbers out, keep adding 3 each time until you hit a number greater than 50, and then count how many terms you've got, and then get your answer. That's fine when it's a relatively small number and what you're doing is really straightforward here, just adding 3. But sometimes it's not that straightforward. You might get a question that says which term is the first to be greater than 3,000. Well, you don't be writing all of those out, adding 3 that many times. So we need a system. And the first thing you do is you find out what the nth term rule is. So to get from 1 to 4 and 4 to 7 and so on, you add 3. So the first part of your nth term rule is 3n. Well, 3 times 1 is 3, but we don't want 3, we want 1, so we subtract 2. 3 times 2 is 6, we subtract 2 to get 4, but it's got here that greater than symbol that you've looked at before in Key Stage 3 and Key Stage 4, because it says which term is the first to be greater than 50. So we do our nth term rule, greater than 50. Now, if we go back to chapter 15 where we looked at linear equations, we want to know what n is. So we have to get n on its own. So again, if this is something you picked up easily, then it'll be really straightforward. If you find it more difficult, you've really got to take your time over this idea. Okay. Remember, when I've said to my groups, things in maths all tie in. So if you found linear equations difficult, you can't just go, oh, it doesn't matter, because it ties in here as well. So we've got to get n on its own by getting rid of the subtract 2 and then multiply by 3. So I'm going to get rid of the subtract 2 first by adding 2 to both sides. So we end up with 3n here because subtract 2, add 2 cancels it out, and 50 plus 2 is 52. I'm now going to get rid of the times by the multiply by 3. The inverse of multiply by 3 is divide by 3. And you actually end up with this answer. So the first term in the sequence to be greater than 50 is a 17.3 recurring term. Well, you don't have a 17.333 term. You have a 17th term and an 18th term. Okay, so let's have a look. If we found the 17th term, so we substituted 17 in here, we did 3 times 17 subtract 2, you'd get 49. Well, that's not greater than 50. We're asked which term is greater than. If we look for the 18th term, we can do 3 times 18 and then subtract 2, and we get 52. Well, hang on, that is greater than 50. So the first term in the sequence to be greater than 50 is the 18th. So this is like those rules of rounding where below 5 you keep it the same at 17. It's not. The 17th term is too small, it's 49. We want the first term greater than 50, so it's the 18th. Okay, have a look at another example together. So here, this sequence, which is the first term to be greater than 100? You might want to pause the video and have a go at this yourself if you feel like you want to have a bit of a challenge. If you're really unsure, I'll just go through it with you. So we'll find the nth term rule. So it's a plus 2 each time, so it's 2n. And if n is 1, 2 times 1 is 2, but we want 3, so we add 1, and that's how we get our nth term rule. And we want to know which term is the first to be greater than 100. Okay, so we've got to get the n on its own. So we have to get rid of that plus 1 by subtracting 1 to both sides. And then we get rid of the multiply by 2 by dividing by 2 to both sides, and we get 49.5. Now if you now feel confident with this, you'll say it's the 50th term, because you can't have a 49.5 term. You have a 49th term and a 50th term. Well, let's just check. If we substitute 49 into here, so 2 times 49 is 98, add 1 gets you 99. That's too small. It says which term is the first to be greater than 100? Well, not this one. So we know it's the 50th now, but let's just check and prove it. Let's substitute 50 into the sequence, into the nth term rule, sorry. 2 times 50 is 100, plus 1 is 101. So that's our first term to be greater than 100 is the 50th, because it's 101. Brilliant. Right, if you could now have a go at these three questions for me. 2 of them are exactly pretty much identical to what we've just done, but just think a little bit more carefully now about C. Please pause the video if you'd like to dive right in and have a go. Otherwise, I'll put a few pointers here just to help you. Okay, if you need some pointers, I've just popped on the first nth term rule for A, and this greater than symbol on 100, you might choose now to work through it. Please pause the video as you do this. Right, good, okay, we'll go through the answers together. So you should have here the 33rd term. For B, you should have had that as your nth term rule, and then you should found out what n was, and then you should have rounded and got the 30th term. Now this one's a bit different, because it says which term of the sequence is the closest to 500. So you'd put equals 500 here, and then you would find the two values it comes between, and you would substitute. So if it's the 99th and the 100th, or the 100th and the 101st, first you'd substitute them in, which is closer to 500, and it's the 100th term. Brilliant. Right, okay, this is a bit of a challenge question, so if you have found it quite a challenge what we've done so far, you might choose to just leave this question for now and wait till you've got your teacher back in front of you to go through these sorts of bits and pieces. If you would like more of a challenge, I'll go through this a little bit more, otherwise you can just fast forward this bit. Okay, so for those of you that want to have a look, I'm going to read through it for you, and then I'll help you do the first part A. So A to B haulage uses this formula to calculate the cost of transporting N pallets. So N just stands for pallets, and it's the number of pallets that there are. And if you really want to know what a pallet is, it's those wooden crossover things that you'll see come out of lorries with loads of sometimes food on or equipment or whatever else it is when they're delivering it to big factories and to superstores. Okay, so you're given some criteria here. So when the number of pallets is less than or equal to 5, that's the formula you use to find the cost. When n is greater than 6 but less than 10, that's the formula you use, that's the nth term rule. And when n is greater than or equal to 11, that's the formula, sorry, the nth term rule that you use. So let's do A together. We're told we're transporting, how much will the company charge to transport 7 pallets? So 7 falls into this criteria here, so we're using this nth term rule. So remember, n just stands for the number of pallets, which is 7. So you just have to do 40 times 7, which is 280, add 25. So the cost is £305. If you feel confident, pause the video, have a go at this B part question. Right, if you're not confident, I'll go through it with you, but you still want to have a go. So this time we're transporting 15 pallets, which fits into this criteria here. The number of pallets is greater than or equal to 11. So we substitute the 15 here, and we do 40 times 15, and you should get £600. Now, if you want to, you can use your calculator for this, because actually what I'm not focused on is your ability to do these multiplications in your head. I want you to be able to apply the rule, okay? Right, I would like you to pause the video now, if you haven't already, and have a go at the next 3 questions. Right, good. So for the next one, you should have 170, because of course the 3 fits here. Then you should have 385, the 9 fits here. And then you should have 480, and the 12 fits here. Well done. Right, what I want you to do now, task 1, complete quiz and video number 198, which is more of finding the nth term rule. And then your second task is to complete the online low stakes quiz by following this link here. So you can find it on the weekly guidance sheet or on the non-video version of this PowerPoint, or you can just type it in. But it's really important that you've done the PowerPoint before you do it. So if you've got to the end of this slide and you thought, I've already done that quiz, you're going to have struggled, okay? So you might want to let your teacher know, and we can organise you having another go. It's not a knowledge recall test, it's a low stakes quiz, just so myself, Mr. Sleeth and Mr. Haste can see how you've got on with the first few lessons of sequences, just to see what your understanding is, so we can offer you the right feedback. And sticking with the Avengers theme, be like Iron Man and get the job done. Well done.